You can go ahead when you're ready, Ted.
Oh my God. Oh, I'm terribly sorry. Welcome this evening to BayChi. And we will have a program this evening about data versus information by Radhika Sawhney. And I just want to tell people a little bit about BayChi and welcome you here. BayChi was founded in 1989, and it's the local San Francisco Bay chapter of ACM SIG-Chi. ACM is a huge organization, Association for Computing Machinery, with over 75,000 members. SIG-Chi is the premier organization for people publishing in research in human-computer interaction. There's about 6,000 people. We historically have been the biggest local group that is associated with ACM around this topic. But anyway, here we are, Zooming for last year, and we do have small costs, but we hope that people can help with them with a $20 a year membership. Please consider joining. Because you're here, you know that you go to baychi.org to find out about us and to be part of the user interface community. We have monthly meetings such as this one, and we have a newsletter, a job bank, consultants to directory, and birds of a feather meetings. For example, we're starting one on jobs in HCI. I want to just make sure we have a chance to talk about the officer elections. I'm chairperson, and there's Edwin Lee is the vice chair, and we have a treasurer, Roberta, excuse me. And if people are interested, please consider nominating yourself or nominating somebody else for the positions. And nominations are open now, but you can send a message to chair at baychi.org, for example, if you want to nominate somebody as well. If there is anybody that wants to nominate somebody right now, I'll just be quiet for a moment as anybody tries to raise their hand in that direction or put it in the chat. So it doesn't happen in this instant, but we are interested in getting more people engaged in BayChi and running it. And on the first Thursday of the month, we have a meeting called the Steerers Meeting. And I call the volunteers BayChi experienced designers. We have a lot of them. People help with membership. They help with this video production, with birds of a feather. We have the treasure. So there's a lot of things one can do. Helping build the web experience is a really tough job that Steve Williams has been spearpointing, and so on. So get in touch with us around that also. And you'll see places to communicate with us at baychi.org. Now, often at this time, we kind of are interested to find out how many people in this meeting might be new, and this is the first time they've come to a BayChi meeting. Does anybody want to raise their hand and say that? Okay, so we have at least one person, and that's great. We have 28 people here. It looks like that's fantastic, and I guess it's a very mix of people that are researchers and practitioners, and people that are just interested also, thinking of joining the organization. So these are some of the things that we have open, and we could please look forward to getting messages for volunteer at bakeguy.org. And I promise you, if you decide to join, to help, we'll probably find a T-shirt for you or something, some way of being proud of your contributions. I don't want to go on too long, and so I just really want to turn this over to Smitha and Nancy to introduce the evening's program.
Thanks, Ted. Okay, I think you can see me right now. Great. So for today, our topic is data versus information. And to go deeper into that topic is Radhika. She has been, of course, in the UX space for a while, doing data viz work, UX research, and strategy and design management. And Radhika, please feel free to introduce your work a little bit more as you get into the topic. And yeah, whenever you're ready, you can go ahead and share your screen. And actually, one more note before we do that. This is a second meeting that we're having on this general topic of the intersection between UX and AI. We had two speakers in March talking about doing research in the space, as well as ethics and AI. It's up on the recording is up on our site. We hope to bring another one of these in the upcoming months, and so you'll hear announcements.
On that topic, actually, Ben Schneiderman, who's a very famous HCI researcher from University of Maryland, has just written a book on this topic and will be our speaker in June. So he will also have a respondent that's an AI researcher from Berkeley. So that should be a very exciting meeting as well as this one.
Great. Well, Radhika, whenever you're ready, the stage is yours.
Awesome. Thank you so much, Smitha. And I'll go ahead and share my screen. All right, I think we're ready to go. So just wanted to start with a little bit of an introduction about myself. Smitha already touched on that. I've been working in the field of UX with a focus on data visualization. I currently work at a company called ThousandEyes, which has recently become a part of Cisco. And ThousandEyes is basically a network monitoring tool, which is analyzing all the traffic that goes through the internet on a daily basis. So we're basically calculating almost 1 billion data points a day, and then kind of trying to visualize that and share that with the users for them to be able to detect outages. And prior to ThousandEyes, I was working with a company called Quid, which is also using machine learning, specifically NLP, to make sense of unstructured data from news articles, from company descriptions, etc., and then help people drive business decisions from that. So that's kind of what I wanted to do today, is basically share some of the learnings that I had along the way on how to take like complex data from machine learning and then be able to adapt that into a visualization that people are able to understand and like drive insights out of. And that's the topic for today, which is like taking data and then converting that into information. So data in itself is a very unstructured thing. It's very raw. It's hard to make sense of in its nascent form. And if it's put in front of somebody, it's like pretty much useless. And where design plays a key role is how do you take that data and convert that into information, something that's actionable, something that's insightful, something that can drive decisions. And that's what we're gonna center around today. So let me jump right into it. Okay, there you go. So let's start talking about what data is like and how it's changing. And that's pretty much an irrefutable fact at this point. Data has changed a lot over the past few years. And let's look at why that is happening. And the key thing to understanding that is to understand the difference between traditional programming and how machine learning works. So in traditional programming, you would have an input and a developer would write a program around it. And then you get an output for a set of results that are pretty discrete and they're pretty known and controlled, mainly because you are writing a program around it. And that differs a lot from how machine learning works. In machine learning, you have an input and you have a desired result that goes in. and what comes out is actually a model. And this is all to say, basically, that it is very nebulous. It is hard to control what your results are. And that's kind of the shift that we need to adapt our mindset to and really understand, like, as the underlying data is changing, how does the visualization change along with it? So what are these changes that are happening? One of the biggest things, and I'm sure like all of us notice this around us on a daily basis, that the data is changing massively in size. It is growing much, much bigger. And here is just an example of what like a single day on the internet looks like. And as you can see, everything is in millions and billions of data points. And this is just like what's going on in the internet. We have so much computational hardware around us, like everything is smart nowadays, our TVs, our fridge, even our light bulbs, and they're just collecting data by the minute, by the second, even the millisecond. So all this is just for us as designers to internalize the fact that there is just massive amount of data that we're dealing with now. And we need to make sense of that. We need to communicate that, since the power of human cognition is not changing as quickly and not growing as quickly. So that conversion and that transition needs to happen. And UX plays a pretty key role in that. Now, besides the size of the data is also changing in what it looks like. And this goes back to my previous slide, where I was talking about the difference between traditional software and machine learning, right? So in traditional software, the results are deterministic. You know what's going to come out. It's an absolute number. It's a discrete number. As opposed to the data that comes out of machine learning, it is more probabilistic. It is more around like what is the likelihood of something happening, as opposed to like something that has happened or is happening. So this kind of goes a lot into the probabilities of confidence scores and things like that. And that is something that we need to understand is the changing nature of the data. So here are some examples of what the probabilistic data looks like. And you can see like this is a lot on the predictive side. Now, while this opens a lot of doors for us in terms of doing like future predictions, it also kind of necessitates this thing for us to be able to visualize that. And we don't really have the necessary tools that we were using traditionally to do that. One quick example for this is for like Amazon 2-day delivery that we are so accustomed to now. For them to do that, they really need to understand what is the likelihood for a certain group of users in a certain location to purchase these items, and for them to be able to plan how's their warehouse stocking accordingly. And that kind of prediction is helping them drive decisions and make kind of actions that help the users in that way. Now, a lot of this data, the more predictive data, is being used by companies to make their decisions, but a lot of that is going to shift towards consumers also going to make that decision. So that is something that design can start playing even a bigger role when we have this kind of variability in being able to select what to do and able to visualize the information in the correct manner. So all of this is basically to summarize that fact that since we have this nebulous form of data and it's kind of changing, what can we do to make sense of it? As we said, the data is much more complex and it's bigger. It is variable and nebulous. It's not discrete anymore. And it is much, much higher stakes. And as you can see in the previous slide, there are all these big decisions that are driving revenues, and like kind of the whole being of the companies, it depends on that. And it's going to get much and much more high stakes in the future as well. So from a UX point of view, it is a big challenge in terms of like, what is the right way to do this? How do we visualize it? And then I will go through some examples and case studies as we go down the line. But this is something that, you know, I would like to just pause and internalize and really understand that the underlying data that we've been dealing with is changing very rapidly. And just to give you an example of how this evolution has been happening. So on the left, I have some visualizations, which are from like the 1960s, from the 1600s and the 1800s, and as evolved to now. And you can see like, you know, there has been over a century of evolution here. And we've been able to evolve from like getting in more interactivity, making it more digital, and being able to code more data basically, and use colors in more effective manners. And then from when you get ML data into the picture, like that opens a whole new horizon and all the different doors for what we can visualize over there. And frankly, we don't have a century to do that because the technology is moving so fast. You probably have like 5 to 10 years there. So this is something like, as designers, we need to understand and we need to start adapting fairly quickly. So how can designers adapt to that? As we understand like our underlying data that's constantly changing, what can we do to help our users? And there are a few points that I'm going to touch upon on this in this presentation, but there's like so much more beyond that. So some of the key things here are, how do we help users navigate through this complex data? How do we help users visualize this fuzzy kind of data where the answers are not very direct and not very discrete and more in terms of probabilities? And then most importantly, how do we access information from that? Since the scale of the data is so high, like we need to make sure it's laser focused and people can get the insights that they're looking for in a very fast manner. And how can design play a role there in terms of pointing those out and making sure those are like very easily accessible and also understandable. And at the same time, people trust that data. So let's take the first point and drill into that a little bit. So how can we help users navigate complex data and a larger scale of data? There's some toolkits that designers have, and both two of them being aggregation and interactivity. And there are some examples that we could look at to go a little bit deeper. But one of the biggest examples that we have here is Google Maps. So when we talk about aggregation, we are talking about being able to go really broad and then giving the whole context to the users for them to be able to see the full picture and get a bird's eye view, and then be able to drill down and narrow into what exactly they're looking for. Because if we are going the other way and start showing narrow facets of data and you lose context, then you're not able to see the whole picture. You're not able to relate how it kind of like comes together. So that kind of going bottom to up and top to bottom is very important, and being able to group it in certain ways for people to digest it. The second tool that I spoke about is interactivity. Now, interactivity has been like a big toolkit for all of the UX designers for a long time now. It kind of helps us do everything, control our lives basically from a mobile phone. But in this case, the interactivity is especially important for us to be able to go back and forth between this aggregated model, being able to maneuver and sift through the data. And there are some examples of how people have done that pretty successfully. So I'll get a little bit deeper into that soon. Now, coming back to Google Maps, as I mentioned, this is like one of the really great examples how you're taking almost all the data in the world and kind of narrowing down on a screen. So they're going from imagining the whole world down to a country, down to a state, and down to every single street on Earth, almost every single street on Earth. So that's basically kind of being able to take a very large set of data and then helping the users navigate and go down to that point where that's important to them to kind of map the route that they're looking for at that point. And this is a very excellent example of how they've done that. Now, in most cases, in this case, for example, like this progression is very clear. This hierarchy is very clear. And in a lot of cases, it does not happen like that. So as a designer, you need to really understand what is the user's mental model. You need to understand what is the journey that they want to take through that data, and basically go from like a high level, how broad do they want to go and how narrow do they want to go? And a lot of time that definition needs to happen and it needs to be set in place before we go a little bit deeper into that. So let me, from here, jump into a few case studies that kind of illustrate this point and that have successfully done this kind of aggregation and interactivity to help control a large amount of data. So the first case study that I'm going to talk about is called Into the Okavango. And this is a data visualization that's been designed by Jared Thorpe in association with Nat Geo and the Wild Bird Trust. So Okavango Delta is this beautiful delta in the middle of Kalahari Desert in Africa. And Nat Geo has been sending almost like yearly expeditions for a long time for them to collect data from the field and be able to communicate that in terms of wilderness and trying to understand like how can they do more conservation and stuff like that. So basically, this expedition lasts over 140 days, and people are trying to get all sorts of data here. So the group of explorers will collect data in images. They're going to collect sound bites. They'll collect videos, wildlife sightings. They might have some social media. And it's just like a vast amount of data that's constantly generated over the 140 days. So you can imagine what that looks like. As part of this project, the goal was to basically have people follow their explorations and then also be able to like look at all the data as they're gathering it in the field. And this has not happened in the past very much. Like it's always been like large unstructured sets that people are trying to make sense of. And this is like happening in real time because as the people are, as explorers are gathering information, they're uploading it via satellite and it's accessible to the general public on like a daily basis. Now, in terms of the design of this, like what I was talking about earlier and how they're aggregating this and creating that interactivity, you can see that it's all structured based on time. And you can drill down from like looking at all of the days into one date into a single time. And then they've grouped this data into like, you can see it in the tiny screen on the right. They have basically types of animals there and, you know, just being able to sort it in different ways. And that makes the whole thing very consumable to people and able to access like exactly what they're looking for. So they're going to go from like the top level to see where the explorers are down to every single image that they're capturing on a daily basis. And as I mentioned, this is like taking that whole aggregation and interactivity model and really making sense of that complex data. Another example that kind of, you know, has the same kind of interactivity is this project called Codis Atlanticus. And this was done by a group called the Visual Agency. Now, for all the Da Vinci fans out there, you know about this book called Codis Atlanticus, which is basically just a huge paper book that is preserved all of Da Vinci's sketches, and it has almost 1,119 of his sketches in that, and it's preserved in Milan. And the goal of this project was to basically make this more accessible to public, where people can go and see this, and then also be able to organize it in a way that's consumable. So they went through this process of taking all of this data and then seeing how can they do that and how can they communicate it to people. So after capturing all the sketches, they categorized them into certain topics that are interesting to people. And they started with like almost categorizing 140 topics and then narrowed it down to 5, which you can see on the screen, and ended up with like an Excel sheet of almost 45,000 rows. So again, like how do you make sense of this data? And as you can see in the visualization, like there is like timeline controls that kind of help narrow down the information. And then on the right, there is also like subjects that people might be interested in, and which were narrowed down to 5 for 140. Again, making that aggregation model happen. And as you kind of interact with this visualization, you can control it through setting the timeline factors, but you can also select the subjects and, you know, drill into them. And as you can see on the right, it kind of like highlights the ones that are related to that subject. And visually, all these pages are also color coded by the subjects. So you can kind of get a very broad glance of how the distribution looks like, and then go a little bit deeper into that. And then once you click into it, you can access the actual sketch and then even navigate from there. So again, going back to the point of like taking this large amount of manageable data, it's like sketches, it's unstructured, and then making it much more accessible in terms of creating that progression where people can start to like break down their mental model as well, and like break it down through different facets like subjects and time, and then go down and narrow from there and always kind of go back and up. And that is really important, in especially when the data is large and unmanageable and more complex like this. So these are the 2 case studies that kind of drove home that point. And to really help think more around, you know, what is the ways that we can start grouping the data in better ways, start to like organize it, and then be able to present it to people that's manageable for them. So the second point that I spoke about is the data being very nebulous and very probabilistic. Like I mentioned, like it's not about the ones and zeros anymore. It's like everything in between. Like what is the percentage of this happening? What is the confidence score around something happening? And that kind of brings us to the point, like what is that what is it that designers can do to kind of help start to visualize that data? And this is something that is very, very common to machine learning. And it's going to happen a lot, and it'll get much and more integrated into the data sets that we're using in the future. So one of the things that designers can do is start getting more comfortable with visualizing many-to-many connections, because the data is not one-dimensional anymore. It is not things that we can just show in bar charts and pie charts and the traditional visualization tools that we've been using. Because now we're talking about a data that might have one connection to another data point and then another data point for some certain percentage, and then those would be connected to another data point. So it's not linear anymore. And we really need to start thinking, instead of trying to like dumb the data down and make it in a linear format to fit the tools that we have, we need to start thinking more around how do we up the tools that we have to kind of fit the nature of that data. And the second thing that we spoke about earlier is around how the data is much more variable. It's not a discrete number, it's a range, right? So it could be that this event is 25, it's between like 25% or 35%. And we need to visualize that range. And that brings its own set of challenges that we don't have traditional tools for. And as designers, we really need to start thinking about how do we visualize that variability in the data. So let me jump into some of the case studies again. So this is an example of IBM News Explorer. And this is a platform that's available publicly for everyone to play around with. This is actually pretty similar to the technology that I was working at in Quid, where what they're doing is they're taking all the news around certain topics and then showing the connections to other news articles as well as people and companies. So if I want to look at something around Apple, I enter that and I can see all the connections there. For example, on the right, you can see how an article that talks about Apple and Google together, and you can see those connections. So the way we consume news typically is like we go to Google search and we'll enter whatever we are looking for. And that gives us a flat list. And as far as I know, a lot of people don't really make it to the second page. You're just going through like the top results that has been kind of managed by Google and page ranked by Google. I am not able to get like at any point a full picture of what is written about everything around that topic. And this is what this tool is helping you do, and also like kind of showing you the connections between the different articles. So here you can see like Apple is the center of the company is at the center of the graph. And then you have all the news articles around it. You can see the distance. That kind of helps you see the connections as well. You can use locations. You can use keywords to drill down and manipulate this data. But it's really showing you the connections that are missing in an otherwise flat list. So the second case study that I have here is a project that was done at PAIR at Google, which is the People and AI Research Group. And this basically talks about the variability part that I was talking about, which is how do you visualize something that's much more nebulous, that's not a discrete number. And here they're basically they're creating a model to predict the likelihood of aftershocks that are happening after an earthquake. So they took data around some existing earthquakes and calculated like where the aftershocks were, and then trained a model to understand like where it's going to possibly be when it happens again. And the visualization is super interesting here, because if you look at the visualization on the left, the black dots are basically where the aftershocks have been observed. That is a discrete number that can be plotted on the graph very easily as a dot. And all the stuff in the red is a prediction. It is where they're likely to happen based on the observed data. And in this case, they've used a color scale to visualize that, because it is, again, based on confidence score and relativity. And there's so many other ways to do it. We just need to come up with them. And as of now, like color scale has been the most common one to show predictions, but there is a lot of scope here in how we can expand that. So the third topic that I was trying to get at is basically how do you help users access this information out of the data. So we have a large scale of data, we have very complicated data. But in terms of the users, and especially like a lot of the times your users are not going to be data scientists or analysts, they might be business users who have to have very little time and very little inclination to start going and like manipulating the data. How do we kind of start focusing and keep them laser focused on the information that they need to find out? And some of the toolkits that we have as designers is like try and really understand. And this actually goes more on the research side, is try and really understand what is the information that they're looking for that'll help them drive the action. And how do we kind of highlight that information and bring it up in front to the user? How do we use the design and interaction to point that information out and kind of guide them through that instead of being able to just present a large amount of data and have the users figure out where they need to go and what they need to do there. So I have an example here of a credit score, which is kind of similar in concept, which takes in a lot of data points just from like different things that kind of help, and then aggregates it into one score that is used for more of an actionable insights. And this is something that we can do with visualizations as well, is just get a little bit deeper in understanding, how do we kind of bring that information to the forefront that actually helps the user. So the example I have here is, again, from IBM. And they basically have the machine learning model called Watson, which everyone's aware of. And this is their business dashboard where people can put in their data and get some analysis out of that. So what they have here is on the left side, they have basically a panel, which is more of an analysis panel for data scientists to be able to get in and go and see the models and see how the data is being generated and kind of get down to the bare bones. But on the right, they have something called discoveries, which is basically them gleaning off insights from this data and trying to like surface high level things that they're finding out in terms of aggregated numbers, or it could be summary statements, depending on how the model is created. So now what this does is, for a user who's more business oriented, who really does not want to go that deep into the data and get in like an overall picture, for them, this panel is interesting because it's giving them like the high level insights that they need to know. And they don't have to go and do that calculations themselves. They don't need to go and figure out how to read the data. They're getting the information that they want here. And on the other hand, if someone is wanting to go deeper and really understand how the models are working, they can do the same and do that on the left side of the panel where they go in a little bit deeper. There is one caveat, though, I want to point out here, especially when surfacing high-level insights, is that there has to be a level of trust that people have to build with the models. So if I'm going to somebody and giving them like very high-level insights and saying that my machine learning models come up with this, and now you go make $1 million decisions based on that, that's likely not going to happen because they need to really understand if that data is correct. They need to be able to go down to the root of it. And in this case, IBM has done a good job by like balancing that out. And if somebody does need to go deeper and really look at the root cause of where that data is coming from to build that trust and credibility, they can do that. So that's something to think about, is like, if we are giving high level insights out of the data that kind of point the users to what they're looking for, there should also be a path for them to go much deeper and really, validate that and make sure that's correct. So the case study that I have here is basically one of the projects that I'd worked on at Quid. And this is, again, highlighting home the point of how can we as designers, point the users in the direction that they need to look at. So this is an example from one of the visualizations that I had. And this is looking at how the news stories are trending, both in news as well as social media. And this chart kind of shows both the sides to it. So one of the lines represents the published count in the news media outlets, and the other one represents social sharing and how this data will be shared on Facebook and Twitter and all these other social platforms. Now, from a user point of view, for me, like ideally, both of these need to be high because I want the story to be trending everywhere. But the insight that I'm really looking for is Is that a difference? Is one high and one low? If the social media part is low, what can I do to ramp up that effort? Is the news media part low, then what can I do to ramp up that effort? And that's the insight that this visualization needs to communicate. So if you look on the right, you have the chart where when you hover, you can see those exact pointers. And in the highlight, it's kind of showing you the difference. And that's the key point that I was trying to write, is making the visualization reflect what people should be looking at. In this case, they should be looking at what is the difference between these two dots. If it's big, it's a problem. If it's small, it's all good. I mean, small and high. So having those highlights and those kind of hover interactions work in that way helps drive home that point. And then you have a lot of control as designers to be able to communicate that information. And that's where we really need to think and make sure, like, are we communicating the right information? Are we able to communicate the information that is really pointed and focused at what the users are trying to learn, as well as the fact that they trust that information? They can go and drill in and kind of validate the source of it. So these were a few pointers that I had and a few examples that you could look at and just basically be able to understand, like, since our data is changing, since machine learning is kind of introducing these new ways, a new scale of data, what can we do as designers to try and adapt to that? And these are just a few case studies that have done it successfully. There are a lot more out there that are kind of like getting at that, but it's nearly not enough in terms of like what we need to do and how fast the technology is advancing. So I would really encourage you to think more in terms of like, what is the future of this data and how do we adapt our visualizations to that? And interestingly, a lot of the principles that we had around traditional data visualization still apply. It is just that the tools, the charts, and the visualizations that need to change and really update and kind of match that data that's now coming at us. So one of the final points that I kind of want to leave you with, and honestly, this topic like warrants a whole new talk, but I did want to touch on it and I wanted to leave you with this thought, is how do you basically go from data consumption to adding on and improving the machine learning models? Now, if you look at all the traditional software development and the data that's been created from that, that has always been like in a snapshot in time. And it's not dynamic, it's not changing. Whereas for machine learning, like we're feeding in a data, and that's basically kind of adapting to the data that we feed it in. So this is to say that if we are not constantly updating the data that's going into the models are going to get outdated very quickly. And they're not going to be as relevant because the data that you fed in is probably from the past and things are changing very, very quickly. So what can design do to play a role in this? What can design do to kind of help augment these machine learning models? And there are a few examples, mainly by Google, that I've put in here. But the key here is to how do we create a feedback loop within the product where we are getting the information from the users to help feed that data back into the machine learning model. So if you look at this example that Google has here, it's basically their newsfeed, and they do it in a way where they kind of provide you with certain stories. And they're typically based on what you're searching for, and there is some intelligence there for sure. Um, and then they also ask you to label things here. So they ask you to, if you would like more stories like that or less stories like that, or would you like to hide stories from a certain topic? And this kind of, what it does is helps them go back to the model and start, changing the content based on how your preferences are changing. Because you might be interested in some news today, but like as events are changing, as your preferences are changing, that changes very quickly. So how does the model adapt to that? It's basically getting that information from the users and being able to do that. And this is a key part of UX that we can think of. We can, how can we start building those tools for people to collect that data and keep the models updated? So it's providing the correct information to the users. It's more centered around their needs. And it's more kind of like adapted to the change as well. So with that, I think I would end here and we can move to the Q&A. And yeah, I think I would just like to leave you with a few points and just, again, drive home and internalize the fact that we really need to start thinking about how the data is changing and how it's going to change in the future, because this change has happened so fast. So we can only imagine like how quickly things are going to go and how we can keep up with that in terms of our visualizations, in terms of how we communicate that data, because without that, it is going to be pretty useless. It's going to be something that people really can't make sense of.
So I think we're ready to entertain questions, right? And so you can either raise your hand or you can, let's see. Ted, you want to speak up?
Yes, thank you for that overview. I'm wondering, is there can you just because you're swimming in data and what you do, I don't know if there's things you can't talk about, but I bet you've had some experiences where you really had an idea, did a visualization, learned from it, that would be very specific and could help us get an idea of what your specific experiences are in visualizing this gigantic, tensor spaces with 100 dimensions and trillions of data points.
Yeah, and I think some of these points that I'm bringing are maybe not like the projects are not mine, but the learnings are very much mine. So I think all of those pretty much cover that things that I've been experiencing personally. And I think it comes down to really first understanding, some places where we've been hurt before is like, what is the right data to show? So you have these trillions of data points and you have different ways, like I spoke about aggregation and interactivity. You have many, many ways of cutting and slicing that data, right? But the point is, what is the right way? What is the things that people are interested in? And one of the examples is basically, if you look at like internet data where I'm working, right? There are so many different measurements there and different ways that people want to look at. People might want to look at the locations where the data is coming from. People might want to look at the servers and get a little bit deeper into that. So it's basically finding those key pieces that people are really interested in, and then keeping updated on that, because those change as well. And just thinking of like, okay, am I surfacing the right thing in the right grouping
Sure.
and in the right way?
I'm just wondering, can you give us kind of some moment when you were looking at one specific thing and then you discovered something, or were surprised by how changing your viewpoint made that insight happen?
So I can actually give a very, very practical example and this is part of like designing data visualizations. And I think a lot of designers will face that. So I think one of the key challenges is basically when you're working with data, you don't really know how it'll end up looking like. So it is very hard to design a visualization when you really cannot see a visualization of that data. So if you're creating a mock-up with fake data, and it actually, when you plug it in, it ends up looking completely different. And you're making certain design decisions based on that. So this has happened a lot where, I've been creating a visualization, for example, a network graph, and you're deciding what the size of the node should be and, what things are based on the data that you have currently available. But then that keeps changing and growing. And that's always, kind of like, okay, how do we adapt to that? So that's one of the moments where you really need to kind of stay ahead and build in for that future as well. And I think that's one of the moments I would say is been that changing moment for me.
Thanks very much. Liam, would you like to make your comment out loud and speak directly to Radhika?
Sure. I guess I can just read it. So, I mean, at the end, great presentation, Radhika. Thank you, by the way. So at the end of the day, I mean, isn't it really about kind of use cases in terms of what users need? So, right, if we're looking at, data set and there's a whole bunch of metadata around it, and, we're talking to the folks who are going to be consuming it, and they're telling us, hey, I want to look at these sorts of issues, these kinds of problems. This is what I'm thinking about. and how do we kind of balance between what we think they need, what they think they need, and then, you know, the new insights that are being generated out of the ML, and sort of, and maybe referring back to what Ted was saying, you know, as people see the visualizations, they, you know, start to learn what's possible, and maybe start to ask new questions, or, you know, want to look at additional pieces of information or metadata. I'm not sure that question makes sense. It's kind of all over the map, but.
No, I think I'm kind of, I can try and take a stab at answering it. And if I didn't, you can like re-ask
Okay.
it. Okay. So as far as I'm understanding, it's basically, yeah, I think there are two ways that you can look at the data, or basically consume the data. One way is basically, you know, as a user, and that's the first point about use cases, right? Like, I am looking at this exact thing. It could be, you know, predicting something that's going to happen, or looking at a number of people that are doing a certain action, and you have that very clear picture in your mind, and then you're organizing your visualizations to point towards that. And that comes a lot from really understanding, like, that's where user research plays a big role. And, you know, that's where you're kind of understanding how do you kind of structure your data to fit the use case and really tell the story that the user wants to learn. And the second side of it is basically letting the data tell the story. And that becomes more prevalent in machine learning as well. So an example of this is like having the machine detect some anomalies in data. So you're going with a pretty blank mindset there, and you're like, okay, within this data set, tell me some data points that really stand out. You know, if this is a group of shoppers that are doing this, we have these X group of shoppers that are doing something completely different. And that data is telling a different story. And that's not really based on a use case. That's just for you to look for anomalies and you to look for things that are beyond the patterns. And that in itself is very insightful. So one of them is more like a confirmation bias, where you know what you're looking for, you go there and validate it. And the other one is more of a discovery factor, where you're just looking at it raw and then seeing where the anomalies lie. And that is the insight for you. I hope that answered it.
Yeah, I think so. I mean, it's a little bit of a nebulous question. I mean, I struggle with this sometimes when doing viz. You know, how do we kind of get at, you know, well, I know how we get at what users want, but it's, you know, this kind of added component of the ML where new discoveries are potentially being made by the algorithms, right? And then how do we present that back in ways that are meaningful and even understandable?
Yeah, and there is a very fine balance you can have about how much you want to control and how much you want to let the data tell the story, because some insights might get missed if you start controlling too much of what you're trying to show there.
Mm-hmm. Okay, thank you.
So Suyash asks, how can we come up with new and creative ways to present data?
That's the existential question. But I think some of the things to do is, at least in my experience, is just look at examples all around. And this is not just to do with like a certain data visualization project. It has got to do just in general life. And, you know, just look at how things are organized, how things are grouped, and then correlate that to the human behavior and how people are understanding that. And I think what I would just suggest is, like, don't be constricted by the technology that we have, the limitations that we have by the product managers. Push yourself, start on paper, and, you know, get some examples from the real world and start imagining, start putting the data together, start seeing, narrow down on the information that you want to look at, and start seeing experimenting with different ways, even on pen and paper, just how to visualize it, because that's the most free you can be. And once you have that, you can, like, you know, definitely be more creative in terms of how that kind of becomes a digital mode. But really keeping your mind open at the initial phase of like, what is the best possible way to see that information? So I don't really have if I had that answer, that would be great. But I think it's just a lot about experimentation, about just keeping yourself very not constricted by the tools and technology that currently exists in terms of visualization.
And he follows up with, great answer, thanks. So Lisa Rose asks, she'd like to hear about your experience testing information design. Does the testing change in real time as the user responds? Say more about how you're doing user testing on those graphs and so on.
Yeah, that's another challenge that sometimes like traditional user experience methods don't directly apply. And I'm trying to think of an example um, where we've kind of done that. So one of the things is, again, in this case, like narrowing down on what we're trying to find out. Are we trying to find out if users are able to understand the chart better? Are we trying to find out if they're able to get the information that they want? And this is very circumstantial. So I think one thing that's really worked for us is doing a lot more task-based analysis. So every time, like we would take this, and this in the past, like if you would take a visualization to the users and ask them to play around with it, you can get a certain set of insights from that, but you really do not get to know if it's useful or not. And when it's oriented around a certain thing that they need to find out, a certain information. So for example, if my user is in politics and I need to make sure my subjects are oriented around that, and it's very tied to the subject when you're testing it. Because if they're not able to see the data that comes out, they cannot really judge if the visualization is good or not. And just to add another point here, I think it's really important to isolate the data and the visualization, because a lot of, like, you're working with data scientists, right? And they're coming up with the data algorithms. And sometimes the data is not good, but you have a good visualization. So if you're showing this together, it's really hard to understand, like, is it that the insights they're getting out of it not good, or are they not able to access the insights? So really isolating these two things helps.
You can raise your hand, or you can type in the chat for more questions. Okay, Alp, I see your hand raised.
Can you hear me?
Almost, yeah.
Great. Radhika, thank you so much for this presentation. My question is, we understand data visualization to an extent. We also seem to do a reasonably okay job with information visualization overall, with some hiccups. What about knowledge representation and knowledge visualization? What can you tell us about that?
So could you elaborate a little bit by what you mean by knowledge visualization?
So, we take the data, turn it into information, right? And then we take the information, turn it into knowledge. And then we take the knowledge and then becomes, supposedly, that's still a debate, becomes wisdom. So I'm talking about knowledge.
I know that paradigm. Okay.
Right. So
I see.
If we talk about knowledge and visualization of that, which has a huge impact in learning and knowledge transfer, what do you think we can do?
Yeah, that's an interesting question, because the fact is that knowledge is very subjective. What I would like to learn, like, for example, in any of the visualizations that I shared with you, right? Like what learnings I take away will be very different from what you take away. And if you're designing an experience, a user experience that's kind of more standardized, like it's kind of, you need to think of it in a more generic way. So the goal of the visualization is to get people to the point where they have enough information to make the knowledge out of that data in their own way. So there is, I mean, I wouldn't say ever that I can give you a visualization that'll make you more knowledgeable. It'll give you enough data points that you will put your own human aspect to, and then combine it, and put together it becomes knowledge. And I think, honestly, that's one slippery slope that we've been hurt by in the past, where if you go down and become too prescriptive in terms of, like, what you're suggesting to the user from the visualization. An easy example of this is if you look at sentiment. And let's say I'm Nike and I'm looking at the sentiment of my news stories. And the visualization tells me if this is positive or negative. But if it goes on to say that, oh, this is negative and your sales are going to drop because of that, like that is the line that, can sometimes be harmful, because there is an aspect that the user brings in their own knowledge that combines with the data that they're getting. And our job is to provide them with those tools for them to form their own knowledge and take actions on that. And this might definitely advance. That line is going to go further and further as our data gets better, but I don't think we're there yet.
Okay, thank you.
So Suyash, I'm going to follow up on his comment. He says, I don't see a difference between knowledge visualization and data visualization in the context of visualization, as knowledge has to be represented in some way. And when you represent it, it becomes data.
Yeah, I mean, that's kind of what I was kind of getting at is knowledge. A part of that knowledge is coming from like human experiences and human biases, and that's really hard to avoid. So that has to be mixed with some much more objective data.
Great. So Michael Yee says, reminds us that the Windows lock screen photo has a like or I don't like feature that's similar to like the news feed more or less feature that you were mentioning. How can or how should it tell what aspect of the photo I like? Is it the subject matter, the color? What is it?
Yeah, that's actually a very good question. And that is, I think, if you can get that detailed information, that's basically what everyone's striving to do. Because like I said, with the machine learning model, you're trying to feed in that information to make it more accurate. Now I'm showing you a photo. I have some sort of confidence that you're going to like it or not. And if the data point I'm just collecting from you is like or not like, then the data that I'm getting from my training model is you like this photo or you don't like this photo, and that's it. But if, for example, in this case, in the Windows photo, it does ask me a follow-up question, like, what do you like about it? Do you like the color? Do you like the shape or whatever? Then I take that information and feed that into a model. Then I can predict much better which photo you're going to like. So it totally depends on the information that you need and how much detail do you want to go into in training the model. And it's also like, this is the last slide where I was talking about getting that feedback, right? You want to reduce the onus on the user as well to give you all that information. So there is a balance between how much you can ask them. Like if I'm every time signing in and they're asking me questions in a very detailed manner in terms of, oh, more like this. So what did you like the topic? Did you like the people? And Google does do that. Like they kind of get into that and they make it optional for people. And if I do end up answering that question, that's just better data for my model.
I'm providing wait time for anybody who might want to raise their hand and they've been sort of thinking maybe yes, maybe no. Come on. You can do it. Well, maybe we've exhausted them. Michael gives a thank you for that answer. And I think that, Radhika, we've come to the end of the night. What did you want us to ask you that we didn't ask you?
I didn't really think about that.
Can you tell us a little more about your background and how you came to this?
Yeah, for sure. So I started in industrial design, and that was a lot of my life was basically more dealing in a 3D medium with more physical products, which was super interesting, and I really miss it. And then just as the industry started to change, I kind of traversed a little bit on the research side. And I worked as a user researcher for a couple of years. And then finally, as a designer and a data visualization, more focus on the data visualization side of it. So it's been a lot of different aspects of design. And I mean, like, this has been the whole genesis of the talk as well. Is like things are changing so much that you need to adapt and you need to kind of like go with the times. And that's pretty much been my career as well.
Great. Smita, you have any follow-up?
Hey, Nancy. Not specifically, but I actually did have one question since I've been noodling on this a little bit. One of the things that I've realized, at least with my work using different kinds of like version or applications of ML, is your data is only as good as your signals, right? And without those good signals, like it's not very reliable in terms of how you present it, what you get from it. So like, what's your experience been, I guess, Radhika, to get, to get at that right baseline, so to speak?
So when you say signals, does that mean like the insights that you're getting out of the data?
No, just the raw data itself, like, right? Like, what are you recording? Does that even like tell you something when you aggregate it, or you visualize it in different ways and you put it together and take it apart in different ways, right? Even having that raw data be useful, I guess.
Oh yeah, and this is a little bit, what I'd spoken about earlier. Is like a lot of insights come from like what you're not even looking for, right? It's basically how the data is shaped. And in a lot of ways, like that takes a lot of experimentation. So when you have a raw set of data, and we're working with like data scientists and researchers, there are like different things you can try in terms of how you're grouping them, how you're breaking them down, what facets you're looking at. And the goal there is basically to see like, is there anything that's off pattern? And that's where the interesting insights lie, right? So a part of it is like when you're kind of deciding what to design and build from a user perspective, you go through this experimentation project and try and see like, are there any signals that are constantly appearing that kind of give me, that shape the data a certain way? Or is it the same every time? And that kind of helps in self kind of imagining, instead of like going in the preset mind that, okay, people need to look at these three data points, but it's more like, okay, this variability is interesting to people. So how can I show that?
So I'm going to ask a question, and that's I'm curious of your review of Hans Rosling's Gapminder style of rendering time series. Are you familiar with that? Where he shows a lot of UN data about maternal mortality against GDP for the country over 50 years or something like that. And have you seen any of this before? He came out of Carolina Institute in Sweden, and I'll just put gapminder.org in
Let me look it up.
the chat if people aren't familiar. Oh, Smita, you and I did the same thing. Good. So, I'm curious, are there other idioms for rendering time series data that are familiar to people? And I feel like his work did a good job, because I could see how China grew in size, and what happened over 100 years time or whatever, where we have the data for it. And not just China, but he color codes by continent, so you can track, is all of Asia doing the same, or is it different, and things like that with these giant UN data sets. A lot of help.
So some idioms basically that kind of reflect that. And like, I think one of the most insightful things for people to see is see data over time, because that's where you're kind of like looking at that baseline and how that's changing from where you're at. And I would say like, now that we have better computations, animation plays a key role there. So a lot of times, we were experimenting with things like sliders that would kind of show a graph at one point and then how that has evolved over time. That's one way of doing that. Or just like an animation that kind of goes from point A to point B. That's another way of doing that. So there has been a lot of experimentation around like, how can you show this data over time?
Right.
There is also a technique that we tried where if you're on a graph and you want to show how the data point is shifted from one point to another, so you're kind of creating a tail that's kind of faded, so you can see like how it's shifted from one point to the other. But I think it's kind of, what is the easiest way? Does someone want to see more of that movement and they're able to consume it? A lot of our users wanted to present things in decks for them, like it didn't really work to have that much animation. So that's why we were thinking more of like, how do we show these trails?
So how do you get, this is sort of related to how you get the inspiration, but what are there websites or books or people whose work you go to get inspired around data visualization?
Yeah, there are, very, very known faces and people that are, doing this. And I've mentioned some of them in my case studies as well. For example, there's Jared Tharp, there's Nadia Bremer. There's like a bunch of individual data artists, and I can like add their links in the chat as well. But yeah, Nadia Bremer, Jared Tharp, Nathan Yao is another one. So there's a bunch of these people who are really, really doing amazing work in terms of data visualization. And those are the ones that are pushing it much more than the traditional UX people, because we're always constrained to a lot of development cycles and things like that. But when you look at it more as a one-off project, then there is so much more you can do, and really interesting work in there. And a lot of it really captures what I spoke about. So with Nadia Bremer, she's done this visualization around Google Trends, where they're looking at, all the information related to cats and dogs, and that's another network visualization. There is this website called Information is Beautiful, which is also amazing. And they're doing some like daily kind of things. For example, they're looking at like movies, which are fact and fiction, and kind of going through every scene. So yeah, there's obviously Georgia Lupi, she's doing amazing work with Dear Data. So yeah, there's some really interesting stuff going on there. What I would really like to see is this happening more at a corporate level, where this becomes a part of everyone's lives. And I think IBM is one company. They actually teamed up with Georgia Lupi to create their design system, which is more
I didn't
focused.
realize she'd done that. Okay, that's cool.
Yeah, so they're basically the first ones who are creating a design system around data visualization, and that is something that we should really think about, because all of the tools we have, their material design, they touch upon it, but they're not centered around data visualization and what are the things we can do to standardize there.
Cool. Well, I think we got close to the end of the time. And thank you so much for sharing all these ideas with us. Very stimulating.
Oh, one thing I would like to mention is also I/O, the conference that happens every year, and that's very centered around data visualization as well. So that's a good one to check out.
So that's the Google conference, right?
No, this is, I can add it in chat.
Sure, go ahead.
It is a different I/O, and that is organized. Oh, wait, I'm not, okay. Let me just find the link, and yeah, and I'll add it as we speak. So that is definitely much more like pushing the creativity of data visualization. I'm just trying to look up the link, and I'll add it in the chat.
Thank you. Now, let's see. Okay. We're busily typing now. That's good. I love it.
Oh yeah, I guess.
Okay. Thank you. Mm-hmm. Very interesting. Good. Okay. Thanks so much. And everybody else, second Tuesday of the month, 7:30 p.m. Pacific. Thank you, those who've called in and dialed in from Ohio and points on the Eastern Seaboard and everywhere in between. And the June meeting will be Ben Schneiderman, as we mentioned earlier. And in July, we're returning to this general topic of AI and UX and attacking it from yet another angle. So we look forward to seeing you then.
Thank you so much for having me.
Great to meet you.